Hi, Viresh. So this is how you solve this kind of problem. And it's about identifying the variables and then using the facts in the problem in order to put it all together. So identifying the variables is as good as going down here where it says, and I've just summarized it here, but the question was specifically find their present ages. So you start off with, now you can do it formally or just in your head, but something along the lines of, um, let X be mum's age, mum's present age, and Y be the son's present age. So there are two things I need to work out. So there needs to be two variables. Okay, now you could use M and S for mum's current age and son's current age, or X and Y like I have, whatever works for you. Then you need to start thinking about the facts that you've been given in the context of these variables that you've just created. So in 4 years' time, so what does that mean in the context of these variables here? Now, if you can't make sense of it because there's variables involved, go to actual numbers and see what you do. So if mum was 10 years, oh, it's a bit bad, isn't it? If mum was 20 years old, how old would she be in 4 years' time? 24, right? What about if mum was 30? How old would she be? 34. What about 40? 44. What are we doing every single time? We are adding 4 to the age. So that means that in 4 years' time, mum will be X plus 4 years old. It says here that mum is 3 times as old as her son. So that means that her son's age, when multiplied by 3, would give you mum's age. So X plus 4 must be the same as, and I encourage my students to see equal sign as meaning the same as. So X plus 4 must be the same as 3 times the son's age. But the son's age also changes over time. In 4 years' time, Y, which is the son's present age, would be would be Y plus 4. Okay, in 4 years' time, it'd be the son's present age plus another 4 years. Okay, what about the other fact? 4 years ago, mum was 5 times as old. Well, I'll break it down for you, but maybe you could pause the video and see whether you can model that yourself using a similar logic. Okay, you either paused or you didn't. So 4 years ago, mum's current age would be 4 years less. That'd be X minus 4. So again, if you can't see it, put in numbers and see what happens. If mum was 24, how old would she be 4 years ago? 20. If mum was 20 4 years ago, how old would she be? She'd be 16. So you can just sort of start getting a pattern of what's happening here. I'm taking away 4 from the age, hence it's X minus 4. And on the right-hand side, it would be 5 outside of Y minus 4 for the same logic. 4 years ago, the son is Y minus 4 years old. Now, we're going to simplify that. Well, that's probably the trickiest bit, and you can probably be okay to go now. I'll finish solving it, but honestly, you could just stop the video now and solve it from here, I reckon. But in case you can't, or you just want to see it through to completion, let's have a look. So I'm going to have to go to the next page for that. So we've got X plus 4 equals 3 outside of Y plus 4. So I'm going to expand that first. So I've got X plus 4 is equal to 3 outside of Y plus 4. So that's going to be giving me 3Y plus 3 times 4, which is 12. And now I'm going to simplify it a bit. I could leave it like that, but I'm just going to simplify it to being X is equal to 3Y plus 8. Okay, I've subtracted 4 from both sides. Okay, I'm going to call that equation 1. The second one is X minus 4 equals 5 outside of Y minus 4. So I am going to expand the brackets there. So it's 5y minus 4. So it's going to be 5y minus 5 times 4, which is 20. And I'm going to do the same thing as well, I think. I'm going to say X is equal to 5y plus 4 to both sides minus 16. That's equation 2. Now, because I've got here x equals this, and because I've got here x equals that, then it must be true that these right-hand sides must equal each other. So I'm going to go 1 is equal to 2, and I'm going to have 3y plus 8 is equal to 5y minus 16. And now I'm going to solve for y. So I look at where the y's are least, it's here, and I'm going to subtract it. So I'm going to go minus 3y to both sides, and that gets me 8 is equal to 2y minus 16. I'm then going to isolate the y by adding or subtracting terms that don't have y's in them. So that means adding 16 to both sides. And I'm almost at the end now. So what I'm going to do is I'm going to swap these sides over because I tend to be a left to right reader. So the 2y that's left over from here is going to go on the left. And the 8 plus 16 from here is going to go on the right. So I've got 2y is equal to 24. And that gives me, I'll just put it up here so I'm on the same screen. By dividing both sides by 2, I get y is equal to 12. So the son is 12 years old. Now I need to work out how old the mum is. So I'm going to use one of my equations to work that out. I'm going to use equation 1 here, x equals 3y plus 8, because the numbers are smaller than this one. That's the main reason why I'm doing it. So x equals 3y plus 8. I'm going to write it again just so I've got it there. So at y is equal to 12, I'm going to have x is equal to 3 multiplied by 12 plus 8, which is equal to 36 plus 8. Hopefully my 3 times table is okay, which is equal to 44. So y is 12 and x equals 44. You could leave it at that, and that would be okay. But if you've got time, you should really answer the question. Son is 12 years old. Mum is 44 years old. So that kind of just, basically I say to my students almost all the time, I say, you should always answer the question. It says, what are their present ages? And if you say x equals 12 and y equals 44, you haven't really answered the question. You've just given me this solution for the variables. This is the answer to the question. The son is 12 years old, the mum is 44 years old. Okay, hopefully that was good enough for you to make sense of the problem. Let me know if there are any more questions.